Hey bio team. So point mutation is a type of genetic mutation that only impacts initially just a few codons of DNA. And it gets its name because it only occurs at just a single point in a gene. So an example of a point mutation would be a substitution. And so here we've got a strand of RNA that codes for several amino acids. And during a substitution mutation, one single nitrogen base gets substituted. So in this case, a cytosine is swapped out for an adenine. And so we have our new strand of RNA here. And in the best case scenario for the organism suffering the mutation, this substitution would end up coding for the same amino acid as before. And this is possible because some amino acids are coded for by more than one codon. However, in the worst case scenario, which is something more like what we have here, this substitution codes for a new start or a stop codon, causing the protein to begin or end early, or it codes for a different amino acid that denatures the shape of the protein. Another type of point mutation would be a deletion. So here we've got the same starting protein, but during a deletion, one or more nitrogen bases gets deleted. And as a result, the rest of the codons shift forward in the nucleic acid, filling in. Now, the end result of this is that every codon after the initial mutation is affected. And as a result, there's the potential for a very big change to the amino acids that get coded for. The opposite of deletion is an insertion, which occurs when a base is inserted into the nucleic acid. And so the result is equally devastating to a deletion, where every codon after the insertion occurs is shifted and affected. And so there's, again, a potential for a huge change to the shape and type of protein that gets made. And so we call deletion and insertion frame shift mutations because they're shifting the codon frames either forward or backward as they're getting translated. And that's it. At this point, you guys have some practice problems. We'll see you next class.